Alright, in this video, we'll be looking at vertical asymptotes and limits that tend to infinity. So in a previous video, we're looking at discontinuities. We've come across vertical asymptotes. So we should be able, pretty comfortable identifying them when given a function, right? But just as a quick recap, let's look at our function f of x. Let's say that our f of x here is simply going to be x squared plus 2x minus 8 divided by x squared plus x minus 12. So whenever we're given a function like this, how do we know when it is discontinuous? Well, we know that a function is discontinuous when our denominator here is equal to 0. So in order to most easily figure out when that denominator is equal to 0, we'll find that we can do that by simply factoring this function. So that'll just make it a lot easier for us. So factoring out our numerator and our denominator will give us x plus 4 times x minus 2. And for our denominator, we would get x plus 4 times x minus 3. And as we've seen in that video on discontinuities, that when our numerator and denominator is able to cancel, it is at that point that we have a whole, which is a removable discontinuity. And where we are unable to cancel, such as this x minus 3, that is where we have a vertical asymptote. So yes, this function does have a vertical asymptote. So that is how we identify it. But now what about finding a limit when we're given vertical asymptotes? How do we do that? Well, if we're given a graph, it couldn't get much easier than that, right? If, for example, we have a graph for a function, so let's draw our x and y axes first. So if we have a graph for a function, like something like this, and 1, 2, 3, 4, 5, 6, something like this, and let's say that we have a vertical asymptote here, and if our function here looks something like that, right, we can see that we have a vertical asymptote here at 2. So then let's say we wanted to find the limit as x approaches 2 from the left of our function f of x, but versus the limit as x approaches 2 from the right for this same function f of x. How do we go about doing that? Well, when we're given the graph, it's pretty easy. We see that as we're approaching this value of 2 from our left-hand side, we can see that this function is tending towards negative infinity, right? We can see that it continues on forever downwards, approaching constantly or infinitely approaching this asymptote, but again, never making contact. So here, the limit is going to be negative infinity. But as we approach 2 from the right-hand side, we can see that it isn't negative infinity, but rather it's positive infinity. This is going to be positive infinity. So in a case like this, as we've seen with previous instances, right, we've been doing limits for a while now, so we see that if we wanted to find the overall limit then for this function, well, the overall limit here, since our left-handed limit and our right-handed limit here do not agree, because that is the case, well, the limit for this function overall does not exist. So hopefully that makes sense. Nothing, we haven't seen anything too crazy here, but again, it isn't too difficult to figure something like this out when we are given a graph. But how about when we're not given a graph? When we're just simply given our function, how are we supposed to figure out the limit here, if it's tending to negative infinity or positive infinity, right? So let's say we're given then a problem like this, where we're trying to find the limit as x approaches, let's say, 4 from the right, and our function here then is 1 minus x divided by x minus 4. Well, firstly, you can see that we clearly have a vertical asymptote here, right? We're unable to cancel out our denominator here, and so when x is equal to 4, our denominator is equal to 0, and again, since we're unable to cancel, that means that we have a vertical asymptote. But how do we know? Is this function going upwards? Is it going downwards? So in order to figure out this is positive infinity or negative infinity, since we have no graph to refer to, what we're going to have to do is simply substitute some values here. And really not some values, just a single value here shall do. And what value is it that we're substituting? Well, since we're approaching 4 from the right, the value that we basically plug into this function is one that is very close to 4, but technically larger. So because we are approaching from the right again. So in this case, what that would be is 1 minus 4 point, let's say 001. This value is very close to 4. Technically, it isn't 4. And again, it's from the right, so it is greater. So now we plug in the same number here again, wherever we see x. So that's 4.001 minus 4. And we don't even have to worry about what this comes out to, right? We just need to see its sign. So 1 minus 4.001, forget about what that would even come out to numerically or arithmetically. We know that this is going to be a negative number. So our numerator would be negative. And our denominator here, 4.001 minus 4, that is a positive number. And a negative divided by a positive, we should know by now that it is a negative number. And specifically, that would then mean that this is negative infinity. So because, again, our numerator divided by our denominator here gives us a negative, that means this vertical asymptote is approaching negative infinity. So yeah, that isn't super difficult. I think you guys can see that it does get pretty simple. We're just using the ideas that we've picked up along the way and just building upon them. So let's look at really the hardest thing that you would see on this topic. So let's say we have a function and we're trying to find its limit. The limit as x approaches 2 for this function, x minus 3 divided by x squared minus 4x plus 4. So if we want to find the limit here, first, again, as always, let's try to identify any of these discontinuities, right? Let's try to see where we have our vertical asymptote. To do that, as always, we try to factor. We can see this numerator, x minus 3, can't be factored any further, so it stays the same. But x squared minus 4x plus 4, yes, we can factor that into x minus 2 times x minus 2. So again, this is the limit as x approaches 2 of this now factored form. So we can see clearly our x minus 2 and x minus 2 doesn't cancel out anywhere, so we do have a vertical asymptote. So now in order to figure out the limit, we do the exact same thing as we've been doing so far. The only reason why I say this is, the hardest example that we'll see is because we're trying to find the overall limit here. We weren't just told to find the right-handed limit or the left-handed limit, but the limit overall, which means that we have to find the right-handed and the left-handed limits, see if they agree, and based on that. So really, it isn't more difficult, it's just a bit more tedious. So let's start then by trying to evaluate the right-handed limit. Say the limit as x approaches 2 from the right of this function f of x. So if we want to do that, we're going to do what we just did. We're going to plug in a number, since we're approaching from the right, that is slightly greater than 2. So that would be 2.001 minus 3 divided by 2.001 minus 2 squared. The only reason I did this is, again, x minus 2 times x minus 2. We can write this as x minus 2 whole squared. Again, if these were different factors, then we would substitute the value is 2.001, for as many x's as we have. We're just doing it in this case because it is the same factor. But anyway, looking at what we have, again, don't even worry about the values, just the signs. So 2.001 minus 3, we know that that's going to be negative. So our numerator is negative. Our denominator, 2.001 minus 2, that's going to be positive. A positive value squared will remain positive. So that means that this is going to be negative infinity. So our right-handed limit is negative infinity. Now what about the left-handed limit? So the limit as x approaches 2 from the left of f of x is going to be equal to, in this case, again, we can't write 2.001, as I was about to do by mistake. Rather, since we're approaching from the left-hand side, it would be a number that is very close to 2, but smaller, technically. So we could do 1.999, for example, minus 3, divided by 1.999 minus 2 whole squared. So here, this is going to be negative once again. And our denominator, 1.999 minus 2, is negative. But our negative number here is being squared, which means it becomes positive. A negative divided by a positive is once again going to be negative. And here we see that our left-handed limit and our right-handed limit agree. So what does that tell us about the function? Well, it means that it exists, and specifically that it is going to be equal to, let's just say over here, negative infinity. So that is the answer to this problem. So hopefully this is making sense. So in this video, we just looked at these vertical asymptotes in a bit more detail, and seeing how limits can approach infinity. Hopefully it made some sense. You got some utility out of this video. If you did, please show your support by liking, subscribing, leave in the comments any questions you may have and what you would like to see next. And I'll see you in the next video.